Hi, in this video we'll be dealing with stock prediction using errors, and I'm going to show you using the previous prediction that we created using scikit-learn, getting new data that should be getting almost the same if not higher accuracy that we got the last time. So if you remember, in the last video we got an accuracy of 93%, and in this one I'm going to be mining new data from min API crypto compare. And if you remember, in the last one, the last date was in about August 20th, and today's date is it's actually March 20th, so it's almost like the same date but a different month, and even a different year. Basically, I'll just be mining data from this year onwards, and I'm going to be doing it for about 30 seconds. Every 30 seconds I'm going to get a new data, and that's how I'm going to be building a new data frame, and I'm going to use this data frame to see how well it adapts to new data. So using this, I'll be able to now show you that the data actually does figure out a pattern. As if you remember the last time that I told you, random forest does actually look for patterns in the data. And using that, the plan is to now work on this, prove that this works, so that in the next video we can be using one of these classifiers, seeing how well it actually works, and implement it in now what's going to be a stock game that actually will be using data in real time and going through a code that actually, because this doesn't actually tell you whether you should invest how much or how little, because when you are investing in stocks you actually do consider how much you're going to invest. In reality, I'm going to now consider the main thing that I need to know is whether I need to buy or sell based on this, and using that, maybe even make an additional prediction system that will tell me whether how much I need to buy and sell, same way there was a prediction rule. So I'll just get to it and now do the imports. I'll leave it that okay, it's finished. So the next step is to just get requests. Using request, get the JSON for the Bitcoin, and it's already received, and the price is now 3,995. And as you can tell now, if I now use the response JSON, I can even get the value as it is. Next thing I wanted to show you here is using time.sleep, you can delay a function, and here what I'm doing is I'm delaying print hey by 10 seconds, and now it's actually printed. Using that now, as I said, I'm going to be using that to get that information. And next step will be just getting the date time that is right now, and using that we'll be able to now get the price and the date and work with them together. So now you can see it's actually on 21st March 2019, and that's what's actually going to be running through the database, the data frame. So now here I'm creating a data frame with date and value rows. Now I'm just showing you the columns and the head, which is nothing in that data frame, because now it's just a blank data frame that I created. So like I said before, what I just need to do is get the current date, get the current price, and append it into the data frame. And if I run all this, you can now see we have a new data frame with the price that you actually got of 3,995. So the next step is to using this function that I created called data retriever, I'm actually going to be looping this query of getting the price, setting it into the data frame, and then waiting 30 seconds, and then doing it over and over again. And actually, until I close this, it will continuously keep running. The good thing though is even if this system actually is set that you're not supposed to actually heavily hit the system. For example, if in their own guideline hitting the URL more than 30 times, more than twice per minute, it's actually they try, and you may actually get an error that says you have reached maximum tries. The good thing is the way I'm doing this, I'm not actually going to be experiencing any issues, because the data is still going to be saved in the data frame. So the next time I still run this, it's going to just append it to the data frame. So I can just safely continuously run this till I get the desired amount of data. And in my case, I want to have at least 260 rows of data, so that way you have enough data to say that because this is a true and false, well, it's called a binary classification, 0 and 1. If the data is up to this point and it's basically guessing almost to a random level, you should be expecting somewhere near 50% accuracy. But if you're getting 90s and above, that actually shows that it has an understanding of what's going on. So using that, I'm just going to get enough data, not basically 260 is more than enough, but this will take a while to retrieve some information because it's doing only 2 requests per minute. And if you can imagine, before now that reaches 260, it will be an actual good amount of period of time. So with this in mind, what I'll just do is leave this running, wait for it to finish, and once it's done, I'll just resume and show you how it looks. One more thing I wanted to show you is the current Bitcoin value since well, for the past 1 year in USD. So you can see that there actually has been a variance so in the data in this time period. Note that when it was starting to train, it only went from about, I believe, 2002 to about August 20th, 2018, and you can tell the price there was about 6,258. And after that, the price actually dropped around, we haven't seen about 4,000 there. Basically, from 6,000 to above 4,000, the graph has gone down. So if the thing, if the prediction system was in any way looking for a pattern, let's say in the price value, it would be getting values that are different than it was seeing at the end of the year. Basically, in that sense, I just wanted to show you the price does have a little bit of variance. So it's about right now, I think I left it at about 200 and something. Yeah, it's 266 entries, and that's enough for now. So let me just move through the final steps of this. Here you can see the head, the tail of the framework. Yeah, using the same process that we went previously, I'm going to create all the values that you are using. This one was actually called value USD. Let me just leave it as it is for now. So we have a date value USD, and this one is just this shifted up: minimum, maximum, open, change, raw, predict, and actual. So doing a shape of prediction and actual shape, the ones which are actually similar. So here I'm checking to see how many prediction values are similar to the actual value. So this matching up with this, and as you can tell here, with almost 265 rows, 213 don't match up. Just do a df to shape again, drop any NAs, X and Y, reload the model, reclassify. Now we've got an accuracy of 94%. and with this ratio of actual, with almost a 50-50 split of 130 and 129, and the price is going up and down. If it was doing this randomly, there was no chance it would be getting almost a 94% accuracy. So I hope with this you are sufficiently convinced that this does actually look for a pattern, and it has found a pattern that is giving it better than average accuracy. Okay, and that concludes the end of this video.